Welcome back, everybody. It is September 6th, fall 2022. We are in statistics, of course. We are starting chapter 3. Chapter 3 is on the numerical summary of data. Numerical summary of data. Okay, and what we're going to do in 3.1 is called measures of central tendency. So we talked about last week 4 different kinds of graphs. We had our graph that looked somewhat uniform, our uniform graph. We had our bell curve. Or bell-shaped curve. And we had our skewed right and skewed left. I'll do skewed left first. And skewed right. These are the 4 main shapes we'll see with data. Of course, I showed the bars here, but all of these would be bars, of course. On a histogram. So you're not going to see a nice little round edge. They're all going to have bars to show them because these will be histograms. So generally one thing we want to do is know where the center of the group is, the average value is. And uniform, it's kind of like, well, everything's got a similar value. It's not the most friendly one to work with. But let's talk about that center thing. Where is the center? Well, for uniform, we might just say it's smack dab in the middle. The center is right here. The bell-shaped curve, we could say it's right in the middle of the center of the hump. I'll use C for center. When we get to the skewed one, though, it's kind of tricky. Like the middle of the picture right here. Let me do something better. Use that paper clip. Like if I do the center of the graph, that didn't come out straight. Let's make it straight. There you go. If I do the center of the graph, well, I don't have hardly anything on the left, and I got a lot on the right. Same thing if I do it on the skewed right. If I put it in the center of the graph, now I don't have hardly anything on the right, but I have a lot on the left. Do I put it in the center of the thing right here? Do I put it there? If I do it there, it's not going to represent the average. So, like, where do we look at center? And that's what a lot of this is coming down to. These measures of central tendency is where do we tend to picture as the center? For the bell-shaped curve, it's kind of smack dab in the middle. In the middle is, we call it the mean, which is the average. And also the median is there, which is middle. Over on the other ones, though, like the skewed left, the mean tends to be to the left of the middle where the median is, and the median is rarely in the center of the hill. For skewed right, it's the other way. The mean tends to be to the right, and the median is closer towards the peak, but still not in the peak. Sometimes if it's barely skewed, yeah, it'll be fairly close. I mean, we could get it where it's just off the center. So we're looking at that, but then like even the bell-shaped curve has some options here. Let me focus on the bell-shaped curve here. This one I made it kind of tall, but what if it was shorter and kind of like did something like that? Like a mountain versus like a sand dune or something like that. They both have the mean and the median in the same spot, but these are drastically different types of graphs. So when we're looking at these measures of central tendency, we care about where the center is. But it doesn't tell all the information that we need. And I'll tell you a little bit more about what we need. I'll give you a chance to finish writing this down. The things we tend to consider for the center is the mean for the bell-shaped curves, but we try to go with the median on the skewed graphs. Okay. Since the mean and median tend to be in a similar spot, you would think we say median for all of them and just be done with it, but we don't. We picked the mean because we like the mean better. It's an average. It's easier to find rather than rearranging everything. You just add them all up. But we'll talk about what those are in a second. Let me leave that up for another 3 seconds and we'll do another page. Okay. So I'm going to draw 3 bell graphs all overlapping each other. Give my nice good bell graph like that. I'm going to do one that comes up really high. And we'll do one that's kind of flat. So all of these have that same center right here. The mean and the median. The blue line, the tall one, remember these are histograms, so a tall bar on a histogram means a lot of entries. So the taller the area is, the more entries are in that spot. So a tall spot like this that's narrow means there is a lot / majority right super close to the mean, right next to the mean. The green one, the flattest one, very little difference really in the height. for the mean in other areas. The blue one is all clumped together. And the green one is spread out. Like if you had it was a pile of sand. The blue one, all the sand stacked in one spot. The green one, the sand has kind of been spread out and like leveled out some. Sure, it's a little bit higher in the center where the mean is, but it's still spread out more. This is called when we're checking for spread. Spread is another form of measurement that we look for because the center doesn't tell us everything. It's also called dispersion or deviation. Dispersion, like how much does it spread out? Deviation, how much does it deviate from the average or the middle? We are going to look at this spread, these dispersions, this deviation. This is going to be in 3.2. We're going to do 3.2 and 3.3 on Thursday. Okay. And so as I was saying, for bell-shaped, we prefer the mean. For the skewed graphs, we prefer the median for our centers. Measures of center. Eventually, in the end, it's the way the what we're going to do is called sampling groups, and what we're going to end up with is a majority of bell shapes. So we're going to focus on the mean. The mean, it comes with 2 letters. So we have different values or different characters for the mean for a sample and for a population. Okay. Sample, we tend to use, we like to use X for our variable. And you'll see it in a second. And a bar above it, a flat bar above it represents the mean. This is our mean or average. Has a bar above it. For the population, we like to use, it looks like a U, but we put a really long, and I'll use a different color for this just to make sure it stands out. There's a long tail in front of it. This is pronounced mu or Mew. Or if you know Pokemon, like Mewtwo. It's a Greek letter. So for populations, we will use Greek letters for a lot of stuff we do. For samples, we will use English characters. We're going to use X for average or mean, and then mu for average or mean. When we get to other stuff, like standard deviation in the next section, we'll use an S for the sample. For population, we will use an O with a long tail on top. This is a lowercase sigma. And this row, these two will be for deviation. Standard deviation. So how do we calculate a mean? The notation they use for it is, here's a little math jargon for you. You don't need to, you'll see it again in the problems more than likely, just so you'll know what it means. They're going to do this big capital E. Then they're going to have an X with a lowercase I. And then they're going to make this a fraction over N. And they will say that is X bar, our average. So I told you this was lowercase sigma. That is the uppercase sigma. You'll see it if you use Microsoft Excel and some of the data processing programs. They use it there. It means sum or add up. We put the I there to say the ith data value. And N is reserved for sample size. Lowercase n is sample size. Uppercase N is population size. We don't shift to a different letter for N or for size when we go to the population. So let me show you what that means using our favorite numbers. So these numbers right here, those are like the I's. So rather than using I, we put a number for our favorite numbers. Jesus, I keep trying to write the numbers for our favorite numbers. X1 is 14. X2 equals 24. X3 equals 10. X4 equals 6. X5 equals 13. So when they say they use this symbol right here, sum sigma xi or sum of xi's, add up all the x values. This right there means for our values, x1 plus x2 plus x3 plus x4 plus x5. For different group sizes, it's going to go all the way up to plus xn, where n is the, again, sample size. That is an I, not a U, sample size. So let's see. The 14, oh, let's do it this way. The 14 and the 6 add up to 20. Then I add 10 is 30. 30 plus 24 is 54. 54 plus 13 is 67. Okay. That's not what we wanted, though. We want to do that. This is my sum of xi for our group. So when we do x bar, we're going to do all those and then divide by n. I already added it up. I'm not going to do that again. 67, n was, I've got 5 rows. 5 of us gave our sample number, our favorite numbers. So n is 5 here. How many times is 5 going to 67? 2/5 is 13.4. That would be our, I'm off the screen. That would be our X bar. Or mean. That's how we calculate mean. I'll show you how to do it in the computer, but I want you to know how to do all these things for what they really mean when you do it by hand. That way you actually appreciate what the computer's doing for you. That's how we calculate mean. When we want to do the median, we have to arrange them in order. And pick the middle value. So I'm going to go through and do these by hand. The lowest value was 6. The next value was 10. Then we have a 13. Then we have a 14. Then we have 24. That would get all 5 of them. So one of the easiest ways to do it is just go inward. Those cancel out, those cancel out. The middle one is right there. The median value is 13. Whenever n is odd like this, we had n was 5 here. When n is odd, it's the middle. When n is even, we have to do some more work. And I'll show you how that works. I'll put our numbers here again. And my friend is a 49er fan. Let's say he likes the number 49. So now I've got 6 entries here. When I want to find the median, I go inward, canceling them out, and both 13 and 14 are in the center. But neither one is the direct center. Like 13 was the direct center here. Both 13 and 14 are the middle 2 numbers. When it's even like that, we average these two. Which means we add them up and divide by 2. This will get the middle value. If you do this, this is 27 over 2, and that's going to get you 13.5. Let's do one more column here with input from the crowd. Let's do siblings. Like, brothers and sisters. I have 1 brother and 0 sisters. I have stepsisters, but let's just include blood. Caprice, how many siblings do you have?
1 brother.
1 brother. Paige, how many brothers and sisters do you have?
1 brother.
Wow. Emmanuel, what about you?
3 sisters and 1 brother.
So a total of 4. Okay.
Yep.
From Malayo, do you have any siblings? I hope I'm not messing up your name. Your microphone is off or on, but I don't even hear background noise. Must have mute on in another way. This will actually work for what I wanted to do for the last bit of information. Another form of middle that we do is called the mode. So the last of our central values is called the mode. The mode is the most frequently given answer. On a histogram, if the bars just represent single bars or single values, it's going to be the tallest bar. If you can do a histogram for it. So in this case, I've got 3 answers that say 1. I've got 1 answer that says 4. The mode on our siblings is not how many times it was repeated, but the number that is repeated is 1. We don't use mode often, but mode comes in really, really handy for certain groups of data. Mode is phenomenal for categorical data. We can't take an average because categorical data usually isn't numbers, and even when it is numbers, it doesn't make sense to average them, like zip codes or area codes for the phone. It doesn't make sense to take the average. And median isn't really all that helpful either, because since it doesn't represent it, if we're talking about hair color, like brown or blonde or redhead, green or blue, any color that we want, silver, white, it doesn't, we can't really find a median. We can't find a mean. So the only option we have is doing this mode thing. Okay. Let's see what else I want to tell you. Oh, for median or mode. So if there is a mode, it's just called the mode. If there's 2 numbers that are the same, so if there's 2 that have the same frequency, we call this bimodal. And this would be like if I had another 4, maybe a 3. 1 and 4 would be both modes. We would list both as the mode and say bimodal. Okay. If there's more than 2, we say multimodal. And if there is no mode, like all unique responses, like our favorite numbers right now. That's exactly what we say. It has no mode. Let's show you how to find all this shit in StatCrunch. And then I'm going to introduce one more topic. In StatCrunch, we can do stats, summary stats, and column. When we do, what we're going to do is, first thing we'll do is select the column or columns that we want to do. The next thing we do is select the summary stats we want in the stat box. And finally, we'll click compute. I'm going to get all the handwriting out of the way so we can, most of it, so we can focus on the computer portion. Because this isn't too bad doing it with 5 numbers. Calculating the mean didn't take too long. But what if you have 200 numbers? 1,000 numbers? Do you really want to add them up by hand? Divide by the total? That's terrible. Definitely not what we want to do. What happened? Rude. Bring me back my data. Oh, you son of a bitch. Alright, I have the values written down. I'll put them back in. $14, 20, 24, 10, 6, 13. And we had 1, 1, 1, and 4. And these were our faves. And these were our siblings. All right, so I'm going to go stats, summary stats, columns. This is because right now I have my data set up in columns. This is generally how you're going to do it. Each person's individual responses make one row. So we're going to stats, summary stats, columns. Then I told you had that first step one was select the column that you want to work with. Let's just work with faves for now. Lots of things are already highlighted. Anything in this box over here is already selected. The white box on the right is already selected. You can see it when I move this cursor up and down. It's the things that are highlighted in blue on the screen right now. When I get to the ones that are not in blue, they're not over here on the right. So the ones you'll use the most is the summary size or the sample size, the mean, and the standard deviation tend to be the ones we're going to use the most. Variance goes with standard deviation, but we tend to do more with standard deviation. There is another one down here that says Unadjusted standard deviation, I'll talk about that on Thursday, what that means. What's the difference between the two? I think it's on Thursday that we talk about it. Let's see. We got our median. We'll learn about range, min, max, Q1, Q3. We're going to learn all about all of that this chapter. Chapter 3 has all that stuff. So let's just do the mean. Okay, and if you want to select more than one, you can click on one and then hold down the mouse button and drag down. I could select them all by dragging down. I don't want to do that though. So I'm just going to go up and click on mean again. If I roll down to where I want to get the median, I can use I'm using the middle mouse wheel on my mouse. Just rolling down to it. When I get down to the other value I want, the median, I'm going to hold down the control key. I think it's your Apple key on Apple. I'm not certain. If you hold down the control key while you click another value, it will add it without adding all the values in the middle. Okay, this is handy. So control plus click to choose more than one. It actually works in the columns too. Do not hold down the control key while you use the middle mouse button. I'll show you what happens on the screen. I selected mean. I'm holding down the control key while I scroll downward. Watch what happens to the screen. It does zoom settings. So I don't want to be zoomed in that close. And now I'm rolling upward while holding down control key to get it back to where I had it at 100%. There we go. Yeah, make it a little bit bigger for what we're doing. So don't hold down the control key until you're ready to click the other item. I'm going to grab medium, I'm going to click it. Then I just click compute. And we calculated both of these by hand, 13.4 and 13. If I want to add more to it, I can do edit. Click on options and click edit. Or you can start up a new one. Let me click compute real quick. Or you could do stats, summary stats, start all over. If you want to just change one setting and you've already got a lot of stuff in there, like I've already got mean and median, I've already selected faves, I don't want to do it again. I'm just going to do that options edit. I want to add in the mode, and I think the mode's at the bottom. Yeah, there it is. I'll hold down control and I'll click mode. And I think up here I'll do both faves and siblings. Show you what it looks like. So now it's showing me both. For the favorites, still the 13.4 and the 13. It's just focusing on the data that's in that column to do it. And it says there's no mode. We had all unique values. On siblings, they added them all up and divided by 4 because there was only 4 entries for siblings. I got 1.75. The median, these are already in order. So we can find the median right here. It's in the middle. They took the average of 1 and 1. And then mode had the most common selected option, which was 1. Okay. I want to illustrate one more topic for you guys. And these are called outliers. We'll see them even more later on in this chapter. But I think seeing what the outliers do and how they change things really could put a damper on it, or what happens. Outliers are values that are extremely away from the center. Doing favorite number doesn't really work. I know a family. I had a student several years back. They said they had 13 siblings. I'm going to include that student right here. And now I'm going to redo the calculations for siblings using a new window, stats, summary stats, columns, because I want to show you the difference. I'm going to do siblings, I want to do mean, I want to do median, and I want to do mode. Notice that the median and the mode haven't changed. 1, 1, 1, 1. The mean changed a lot. It doubled. So outliers can heavily affect the mean. They can, I should say. They don't always, but they can. But they rarely affect the median or mode. They rarely affect the median and never the mode. And the effect on the median is negligible. When a summary statistic, summary stats that remain unaffected by outliers, we call them resistant. They resist the effects of extreme values. So the median and mode are resistant. The mean is not. Another good way to show how outliers affect things. Let's do money in the bank. Rather than asking you how much money you have, I'm just going to give you values. So I think I had 3,900 in the bank. Everything else is either invested or something like that. And I haven't paid my bills yet this month, so a lot of that's going to get eaten up. Let's say Caprice has 3,500 in the bank. Let's say Paige she's been a better saver. She's got 4,900. Emmanuel, he doesn't like to save. He likes to spend everything. He's got 1,000. And Famalayo, let's say Famalayo is like around mine. Let's say 3,950. So I'm gonna look at the summary stats for them. For these made up numbers. So my mean is 3,450. The median is 3,900. Then Elon Musk walks in the room. How much money do you think Elon Musk has got in his bank that isn't tied up in investment? I bet he keeps a chunk of change, a good chunk of change, just in case of a rainy day. Doesn't want to have to sell investments. And he's got so much money, I bet he can get away with having $500,000. Just treating that as a rainy day fund in his account. Watch what happens to the statistics now. The mean went from $3,450 to $86,000. Notice $86,000 is more than any of us have in the bank except for Elon Musk. So adding something that's an extreme outlier really destroys the mean. It really has a huge impact. So much so that when we do statistics, sometimes we exclude or omit extreme outliers. Now, it may not be an outlier. Maybe if there's only 6 people, I just chose 5 people that had a lot less money and the 6th person is normal. But if there was 1,000 people in there with all of our money like that, and then along came Elon Musk, he's definitely an outlier. It's clear he's an outlier. He's not representative of the people in the population. So using him to describe averages and stuff like that doesn't serve a good purpose. It kind of like it's not really, it doesn't represent the population. So sometimes we can choose to omit them. And so we would just say delete. I'd maybe keep the number saved somewhere else. Put the 500,000 back here. Let's see if I can Control C and copy and paste. Oh, I can. Look at that. So money in bank or money, no outliers. I would do that to preserve the data if I needed to. Keep that in mind in real life. For the stuff we're going to do in this class, you're not going to omit an outlier unless the homework specifically says to do so. But in real life, it's a common example. We've done, when we were in person, I've had people for the project at the end of the year or in the semester go, how much money did you spend on Christmas gifts? And we found like an average. If we had Elon Musk in the group, he would destroy the average price or average amount spent on Christmas gifts. He wouldn't be a good reflection of the population. We'd probably I would have told them to admit him or recommended they admit him, because otherwise it's going to not be realistic. And when I say not realistic, we can see this $86,000 mean is not realistic when these are the numbers. Okay? Do you guys have any questions? That's all I've got for you tonight. Oh, Manuel's already gone. Okay. If you have no questions, have a good evening.
I think I have a question.
Okay.
So hold on just a second.
Okay.
Is it okay if I share my screen with you?
Yep.
Recording stopped.
Okay.
Stop the Zoom one. I'll keep the other one going in case you got something that is good to share with the students.
Okay. So you just went over this. This is the second question on homework 3.
Okay.
What does it mean by the mean strength? Does that just mean the mean?
Yes. When you're reading it, notice the last sentence, not last sentence. Oh, yeah. The last two sentences, it says the following data represents the strength of 9 randomly selected casts. Compute the mean, median, and mode strength of the concrete. So how much pressure can
okay.
it resist? So you can
Okay, that was
see the little blue box right next to your numbers. Do open in StatCrunch, and that way you avoid copying them over and making mistakes when typing. And you can just do it here. So you can do the same what we were just talking about. You're going to do stats. You'll go to summary stats. You go to columns. Click on variable 1. And on the left side,
I leave this the same?
You can, but I recommend practicing choosing what you want for now. So click on mean. Scroll down and click add, control-click median and mode. Right next to where it's mean, there's a little, let's see, that thing. You can add them in there. Mode's at the bottom, median was higher up. So you got to hold down control when you do it. So scroll back up. That's why I've been having you do it. It's a training exercise right here. Scroll back up. Hold down control, click mean. You're not holding down control, are you?
I am now.
Okay, median's right there. Hold down control. There we go. There you go. Now click compute.
Okay.
So that'll have all 3 answers. That way you don't have to do it more than once.
Okay, thank you.
Uh-huh.
I was really confused. Thank you.
No problem. If that's it, I will see you guys on Thursday.
See you on Thursday.
Okay.